The manufacturing industry is undergoing a dramatic transformation, driven by rapid advancements in artificial intelligence. AI is revolutionizing production processes, leading to unprecedented levels of efficiency, quality, and flexibility. From automating tasks to predicting equipment failures, AI is reshaping the factory floor. This essay explores how AI impacts manufacturing, driving innovation, and creating new possibilities. AI empowers manufacturers to optimize operations, reduce costs, and enhance product quality. By leveraging machine learning and data analytics, manufacturers gain valuable insights and make data-driven decisions. This leads to a more agile and responsive manufacturing environment. The integration of AI in manufacturing is a fundamental shift in how goods are produced.
AI is transforming traditional manufacturing processes by automating production lines. Robots powered by AI perform complex tasks with precision and speed. They handle repetitive jobs, freeing humans for creative tasks. This improves efficiency and workplace safety. Machine learning enables robots to learn and improve over time. Analyzing data helps optimize movements and reduce errors. Collaborative robots or cobots work alongside humans. They assist with tasks, enhancing productivity and flexibility. AI-driven automation increases output, reduces costs, and improves quality.
Predictive maintenance is another area where AI is making a significant impact in manufacturing. By analyzing data from sensors and machines, AI algorithms can predict potential equipment failures before they occur. This allows manufacturers to schedule maintenance proactively, minimizing downtime and avoiding costly repairs. Traditional maintenance approaches often rely on scheduled inspections, which can be inefficient and may not always catch potential problems before they escalate. AI-powered predictive maintenance systems leverage machine learning to identify patterns and anomalies in data collected from various sources, including sensors, machine logs, and historical maintenance records. By analyzing this data, the system can detect subtle changes in equipment performance that may indicate an impending failure. This early warning system enables maintenance teams to take corrective action before a breakdown occurs, preventing costly production disruptions. The ability to predict equipment failures allows manufacturers to optimize their maintenance schedules and reduce downtime. Instead of relying